2000, my study area, 2004, the big tsunami hit in the area. I will show you after the what are the development happen in this area. Actually, this is a highly risky area, but the policy government doing what are the development in this area. See, just in the background photo also showing this is the one of the creek near Chennai. There is a thermal power plant. See, thermal power plant in the creek wetland area they constructed. We'll see that. Okay, sorry. Just I will give the brief introduction about our Indian coast. Indian coast. So Indian coastline nearly about 7,500 kilometer, including the island also. So mainland 6,000 square kilometer. Here is the Andaman Nicobar, and here one more island is Lakshadweep is there. So it all comes under the Indian territory. About 17% of the populations living in the coastline. And then we have the states, nearly 7 states and 4 union territories, like federal states. Then the islands also falls under that. There are 76 coastal district administrative unit in the coastal area. Then 77 cities, towns located in the coastal line. Major 3 metro cities, Kolkata and Chennai and Mumbai falling in this coastal region. So this is our. Then coming to my study area, this is the southeast coast of in India, southeast coast of this one is the Tamil Nadu state. So I taken for this study is the entire this region. This is the 2004 tsunami time. It's a highly affected area in this region. Thousands of people's fertility happened in this area. So nearly 3,360 kilometer long coast. 30% of the populations living in this area compared to the state, 72 million people, 30% living in this coast. The Chennai city is here. The population density nearly 25,000 inhabitants per square kilometer. So this is. Then you can see there is a 17 industrial ports. There is industrial ports, private ports, fishing ports. All is happening within the 360 kilometer. We have all artificial ports. There is no one natural ports. All are artificial ports. Then 5 thermal plants in this area. Then 1 atomic plant also. So the situation is this is okay. Then nearly this zone is 53 square kilometer aquacultural, prawn cultural, shrimp farm cultural is happening in this region, this zone. So this is our just introduction about our coastline. So coming to the physicalism, this is a low-lying sandy coast. There is nothing cliff. Is a fully 1 to that's why 1 to 5 meter elevation only. That's why any storm surge, tsunami time, our the damage is more in this region. Fully flat land. This region. See the last 100 years cyclones, 1960. From the 1962 and 72 cyclones happened in the only this region only. I taking account only this region. 72 cyclones last 100 years. 2 to 3 cyclones averagely hitting this region. Then major floods is a 2005 event and 2015 event because of the cyclone only, depression. Then the last largely affected by the 2004 tsunami event. So this is our area. Then coming to the significant coastal vulnerability along the Coromandel coast. This is all I can tell the natural or man-made. We can tell man-made also. Sea level rise because of the climate change is one. Then the coastal erosion. This is both man-made and natural. Then cyclonic storms. These are. Then another vulnerability is in demographic population growth. It's happening here. Then ever-growing industrial and harbor areas. Then the aquacultural and nowadays last 10 years, lot of beach resorts for the tourism purpose coming in this coastal area. So the highly risky area, but this much developments happening in this region. Then saltwater intrusion, because of the population increasing, saltwater intrusion it's happening, because over exploitation. So one by one we will see the just first general study we will see the sea level rise. According to the IPCC, 1901 to 2000, 1.7 mm per year. Particular 1993 to 2010, 3.2 mm per year. I think most of people will know this report. So if it in the same case, 2100, it's possible to half a meter to 1 meter sea level rise. It's a general IPCC report. Coming to the Indian scenario, there is one paper is there for 1993 to 2012, 3.2 mm per year, the average. Particularly northern area of the northwest, the Kolkata area, 5 mm also they're telling, the Gangetic Delta area, 5 mm is. What is this where increase the shoreline erosion it happen, loss of wetland and flooding. This is a slope poison only. Now but is accelerating more. Then next process, coastal erosion process. The coastal erosion process is the natural and anthropogenic also both. So coming the natural is the wind tide, but that natural also is induced by the climate change. Because of the global warming, the seawater warming, there is a more nowadays more cyclone, more tropical cyclone, and the intensity also now is increasing. So the climate change, that also is the anthropogenic effect. So here storm surge, wave, wind driven current, this is a natural factor for the erosion. Coming here, sea level rise, land subsidence, then alteration in the coastal dynamics, constructing the port, all that also is, I will show you the examples, constructing port, that also then coastal infrastructure, mining, then dam also, there is lot of dams. The same, after the British people came, here is the Spanish, in India, British people came, they constructed the more dams. So the sediment flow is less. Then the same case for the landslides, they deforested all the forest area, the plantation, tea plantation, they did the tea plantation, coffee plantation. Automatically the urban growth also is more, this happened. The same changes, they construct lot of dams. So the sediments coming in the less, that also is the reason for this. So this is the coastal erosion is happening both in this one. So just breaking the, it's just phenomena of the breaking the waves, remove the sediments, then the currents transport the sediments. This is the basic one. So for the monsoonal wave forcing, in this study I used all freely available data only, because in India getting the data for the coastal data, getting data is very difficult. All the wave data, wind data, all is getting data. So I used for freely available is daily wave data from Terra Interim. Since 1977 I taken oceanic currents data from 1993 to 2015 from Mercator Ocean, Copernicus Marine Environmental Monitoring Service. I taken from this data. So from that we derived for some of the current velocity and wave energy for the nested. So just the result of the wave energy direction. See here the minimum value to the maximum. So coming to here is the maximum wave energy is here. This portion is wave energy is more. Here also this is the wave, the next one. Then current velocity. So current velocity also is more. So this is the more vulnerable area in this region. This is the current velocity also more here. This is natural one. Coming to the, I will give the one example, anthropogenic. There is a 17 port, already I told 17 port, one port. This is my native, I am living in this town only, Pondicherry. So here they constructed this is the old picture, 1950, we have good beach. So they constructed the port in the south of the city, 1979, 1989 they constructed. Afterwards, see, the port constructed, the harbor constructed here. The time they breakwater constructed. Afterwards, erosion has happened in the northern side. This is a purely man-made erosion, anthropogenic effect. So the harbor built in 1989, nearly 350 meter breakwater seaward side. So this breakwater it's stopping the sediments. Normally, the sediment movement is May to August from south to this direction, south to north direction. Only October, December, only north to east direction. The 70% of sediments is moving here on south to north only. So, construction of the breakwater, the sediments is deposit southern side. So, the city is here. So, now we are happening erosion. Now they made it sea wall on that area. There is no beach. They made sea walls only. We are protected by the sea wall. So up to now, interestingly, up to now this is the one federal state. The next one is another state. What's happened? This erosion is changed to the next place. Sorry. So up to level, they constructed the groins. So each groins now, yeah, this is the construction groins. So here is the accumulation is going north of the groins, erosion is happening. So it's moving towards north. Now this side villages or people are affecting erosions. They are agitating for this. So this is the man-made erosion is happening in this one. Like that, all the, even Chennai, I will show the Chennai city. Chennai city also is artificial harbor only. So the south of the Chennai is the good beach, Marina Beach. North of the Chennai, the city, so fully erosion is happening. I will show the photos afterwards. Okay. The overall scenario of the India's one. See, this is the paper of the Rajvat, etc. Erosion is happening 45% in India, 18% stable land, aggregation is 35. Overall erosion data. Coming to the next cyclone storm, already I told last 100 years, 17 cyclone storms hit in this area. Last 20 years, 11 cyclone storms and depressions happened in this area. So the reason cyclone storms in this area, Thane 2011 is the damage is more in this region. Then the very latest last year happened this one, 2008 one. This one my colleague Professor Lashmanan will detailing will tell about this Gaja cyclone affects this one. This is the region. So this is the all current situation. Then the possible future climate changes scenario in this based on the Krishna Kumar et al. Decrease in number of rainy days and increase in the intensity of the rainfall on given rainy days in the future. This one. Next, extreme in rainfall and temperature are showing in increase. The third, no significant changes in the frequency of cyclone storm, monsoon depression, but intensity of storms see higher than 10% in the future. That will happening now. Now all the cyclones intensity is very high. Then demographic growth. I taken from the demographic growth 2001 and 2011 in this area how much is changing also. Afterwards I will explain one by one. Then this area land cover changes. I taken from the high resolution, very high resolution images. From the freely available, there is in the ESRI software, ArcGIS software, there is a one world level very high resolution image is there, for satellite image is there. Afterwards, then I used Google Earth images also. In India, purchasing the very high resolution image also is the expensive plus restriction also. We need to give a proper explanation, then only it's possible to get the below 1 meter resolution images. That's there. Same in the elevation also. We are using only the 30 meter freely available SRTM allows only. Impossible to get LiDAR data. It's a very restriction in India's. Okay. Then I use the method just visual interpretation only. So I use the free satellite images, high resolution, Google Earth, and then visual interpretation only. We mapped all the industrial, urban area, the natural all ponds, mangrove area. So major land use classification we classified in this region. Then harbors data we taken from our maritime board websites. A number of the harbors we taken. Then results of this land use land cover, ever-growing industrial combines with dense urban agglomeration and harbor areas. Then aquaculture, beach resource expansion increasing in this region. This is changes from 2000 onwards only, 2004 onwards only, after the tsunami only. Okay, coming one by one, the major results. First, nearly 90 kilometers. This is the Tamil Nadu state. From the north, this border to nearly 90 kilometers. This area fully industrial and urbanization conversion in this region. Next, coming to 100 kilometers, this zone urbanization and beach resorts. Most of the coastal land transformations. It's not entire not regional. Most of the land coastal transformation. This region is industrial. Here is the tourism. A lot of beach resorts coming in. Then this 50-kilometer area, this region, nearly 40 kilometers, the Kadalur one district, full and full industrial conversion. This region fully industrial conversions happening in this region. Then the final zone, this zone, it's fully aquaculture. Okay, sorry, I will. This region is industrial and is a beach resorts nearer to our Pondicherry beach resorts. Okay. And then here the industrial zones and the aquacultural practice happening in this region. Okay. Then one by one region we will see from. So an industry and highly populated region. The industry are mainly petrochemical, oil refineries, manufacturing within from say coastline to within 5 kilometer. All maximum 5 kilometer. All industry are very mainly petrochemical, oil refinery, manufacturing fertilizer, paint and paramedic is there here. Then 2 thermal power plants and 3 important harbors in this region is there. Then industrial and urban areas encroached into the wetlands of the Pallikarnai marshland and Enir Creek. This is the that's why I told this is one of the man-made disaster, the 2014 flood. Because of the Pallikarnai marshland, nearly 1,400 acres now is reduced 600 something only. So the entire marshland is like a good shock absorber for the flood. This one floods. But now they occupied fully. There is IT in the IT offices. There's a lot of IT offices. Then residentials came in the Pallikarnai area. Same in the Ennur Creek area. All industrials, thermal plants. Then thermal plants waste, ash dumping. I will show that photos. Ash dumping. So because of this only, we got a lot of flood damages in the 2014 time. Then coming another hand, the population increasing 20% from 2001 to 2011. So the risk is more increasing. Then another hand, even the population is increasing in the 20%, but number of household increasing in 35% in the coastal area. Then there is a significant coastal erosion happening places in the red marks. That's why I reported it. Then the last one of the 16 Varda cyclone happened here. Okay. Just one example. This is the 2004. Just coastal sand dunes and coastal vegetation only in this area. Just 2014. Industrial. All I grabbed small area only. If you see the entire area, I will show you the after. So 2017. This is a coastline. This is very close to developments. All. So here I will made it to this entire area. So build up land, any industry or residential, 22% only. 2006, 2012, nearly 37% total area in this region. 2017, 47. So now one more port is coming in this area. Okay. So I will already show the north of the Chennai situation is fully, it's a full seawall and her groins only. Just the seawall groins. Here is the 100-feet road, because it's from the port. That's why it's a big road. Then all very poor settlements this region. All. Then coming to the next zone. This is the next zone. I already told this is the most of the conversion is the beach resorts here. Fully many beach resorts. Then one atomic power plant also is here. Okay. And then yeah. So 2014, lot of happening. So entire nearly 8. There is a one road 2002. They are happening East Coast Road. After the road arrived, there is a lot of tourism activities happening in this area. So too many resorts is coming in this region. So now the Pondicherry city, already told, my city is fully with sea walls only. So now it's called as a rocky beach. For the tourism people are using rocky beaches here. Okay. Yeah, this is the, I told this is the groins. The south of the groin is the accumulation. The north of the groin is the erosion. It's happening in this region. So the next third zone, I already told, dominant industrial area. Kadalur district is rapidly growing industrial zone. Presently, there is a 14 major industry, one thermal power plant, and one oil refinery close to the shoreline, and 5 harbors, fully private harbors for the this purpose, for coal and oil refinery purpose only. Then Tamil Nadu government has recently declared 45 villages, this area, petrochemical zone. Petrochemical and petrochemical investment zone, 45 villages. It's a good deltaic area, delta area. Then here is the Pichavaram, one mangrove area also mangrove zone is there. Surrounding, they announced 45 villages for the PCPR, petrochemicals region, this region. So this is already, this zone is very highly vulnerable zone. Now because the tsunami has happened, then already I showed the 2 to 3 cyclone is coming in this region. So even though the government is the policy, they are announcing this. So just one images is 2006. That time only they acquired for the oil refinery guys. They acquired, they cleared. Now before that we don't have the high resolution image. So that is 2000 they land acquired. This is before sand dune area, sand dune and coastal vegetation area. So now there is conversion. Here is the small fishing hamlets. So after oil refinery industry came here, they constructed the private port jetty for the raw material. Because, so that purpose only they constructed the jetty here. So once the jetty constructed, the fishing villages shoreline is gone. See before photo, this much shore is there, shoreline is there. Afterwards, the erosion is happening in this region. So then they did the grinds, this style. So this is this area scenario. 2006, 11% build up area, then 22, now it's 24. I taken, this is a 5 kilometer width only from coast to that east coast road. I told the east coast road is a 5 meter maximum, 5 plus minus only. Here is very less only. Here is the max 5 meter. Coastal, nearer to coastal. The last one I told is this zone is mostly converted in the aquacultural, nearly 5,000 hectare agricultural land and wetland converted into aquacultural ponds in this region. Then the PCPR program, the same, the petrochemical region, here is the 20 villages falling in this region also. Here is another interesting thing, one more Ramsar wetland also is here. That area that nearer to there, a lot of salt industries going on, salt in there. See that area, yeah, 2003 and 12. So because of the thermal power plant, they made the port, so just here. So entire this region aquacultural. This is directly taken from the Google Earth. This much, nearly 53 square kilometer under this. This is all agricultural land or wetland, the coastal wetland. They converted for the aquacultural activities. So the overall scenario of this region. So the current situation, wave energy, and then erosion happening, major erosion happening places. Then the cyclones last 20, I taken only for this one, 20 years, last 20 years cyclones where it happened in this region. Cyclones and deep depressions. Then a large industrial complex, atomic power plants, and the port. So this is the situation after that. So when the socio-economic, these are two papers. One is the JCR, this paper is from JCR, then another one is natural hazard paper. This studies is available in these two papers. Okay, afterwards, I taken only the fourth zone only to identify the risk area. just the fourth zone, the Nagapattinam zone, that is the only the aquacultural, that area. This is a study area. So main identification for the major hazards in the Nagapattinam coast, coastal vulnerability index, I made in the index, and hazard zone demarcation in this region. Okay, just geology, fully recent alluvium area only. This is a beach region alluvium. Then geomorphology, already I told, it's a very flat area, only uh, uh, beach riches, coastal plain, deltaic plain only. There is no ridge, nothing. It's very flat terrain in this region. Just photos of the different geomorphological photos in this region. Then rainfall of this area, nearly 1,200 millimeter rainfall. Okay. Then the past event, this area, 1952, you can see, storm surges happened in these 5 miles, 400 lives, like 67, 77, 84, 91, 2004, 2011, then 2018 also, the previous 2000 has happened. So this is a flood. Same time, drought also. So 86, 67, 80, 82, 95, and 2002, this region. So the major risk vulnerability area based on the shoreline changes, then inundation risk analysis, evaluation coastal vulnerability index, then land use land cover changes, then finally saline water intrusion coastal aquifer. So the 5 factors I taken for this one, just different data I used for this study. Okay, just first shoreline changes, topo sheet, and satellite images I used for this shoreline changes study. Just using that satellite image, I extract the shoreline, then overlay analysis did by the GIS software. Just the changes from 1972 to 2017, where the erosion and aggregation is happening. So the erosion place is more vulnerable for the risk area. So inundation risk analysis. In this region, already I didn't forget to tell, storm surge, maximum possible storm surge from the Indian Meteorological Department, 3.5 meters to 4 meters. Then the tsunami averagely came 5 meters, average is 5 meter height it came in this area. So based on that one, I created the inundation risk analysis. See, I used the Aster digital image, digital elevation model, 30 meter resolution. Of course, the elevation accuracy is 8 meter, but unfortunately, there is nothing other resources. If you use the topo sheet, Survey of India topo sheet, there is a 20 meter contour, nothing in the coastal area, nothing. So compared to that one, this is the good data source for the Aster digital elevation model. Then here is a satellite image I used. So this is 1 meter to up to 5 meter, 0 to 1, 1 to 2, 3 to 4, 4 to 5. So up to 5 meter. If it the storm surge, for example, storm surge, it will come 1 meter storm surge. Then the normal wave height is 1 meter, 1 plus 1 to 1 plus 1 or 1 plus 3.5, 4 meters, 3 meters. If it will come, how much level in the water it will inundate in this area I use. Then what are the land use it will affect. Here I am showing this one. So this is the table of this one. If it 1 meter will increase, agricultural land, this much it will affect. Like that is the table. If it 5 meter, it will inundation will come. The agricultural land this much level, then mangroves, mud flat, and the settlements, nearly 17 square kilometer settlement it will affect. If once 5 meter run up will come. Then I did that area directly settlements from the high resolution Google Earth. I taken wherever the houses is there, I delineated the housing area. So in the housing area, this much nearly 16 square kilometer it will affect. If it 5 meter will come, it will affect this one. So finally the affected census villages. Then only we know the how much village is affecting, how much household. Now because this is useful for the policy. Disk is useful. Disk management people is very useful. So these are the villages falling under that category. Number of houses, population is there. So the management purpose, this data is very useful for them. Then okay, I did the coastal vulnerability index. I used for this index, I used develop USGS one only, the simple one only. So here I used two variables: geological variable, physical process variable, erosion, geomorphology, coastal slope, then sea level rise, mean tide range, mean wave height. Based on that one, ranking. For example, geomorphology, rocky sleepy coast, very low vulnerable one. The same time, sandy beaches, mud flats, mangrove area, very high. Coming in my study area, mostly falling in this category only. And all high risk area only. Like that, all the parameters is. So using that one, so every kilometer cell, one cell is every kilometer, low, medium, high, very high. If you coming the very high, nearly 71 kilometers falling in this very high region. The percentage of this is 30. So what are the villages falling on the low, medium, high? Then only they useful for the management purpose. So if you take the Vedaranyam, 5 kilometers coming under the medium, one high, very high. So we give the important for very high area. Okay. Then land use, land cover changes in this region. Okay, last 2 decades. So major changes. Agricultural land decreased, plantation decreased. Other hand, settlement increase, salt pan increase, aquacultural increase. This is happening in this. Okay. Then vulnerability assessment was saline water intrusion in the coastal aquifer. I used the Galdit model for that this study. So this is a simple model. Just a major area I identified for where the saltwater intrusion in this area. Groundwater occurrence, aquifer hydraulic conductivity, depth, groundwater level above the sea, distance from the shore, impact of existing status of the seawater intrusion in the area, thickness of the aquifer. I used fully all secondary data only for this study. Secondary data, I got the data from the PWT. So this is the criteria, just the groundwater occurrence, the aquifer type, already is the multiple aquifer type, then hydraulic conductivity of this region, then depth of the groundwater level, see from depth of groundwater level, then from distance from the coast up to 1000 meter I taken, then impact of the existing say sea water intrusion, the calculated average from Cl plus HCO3 plus CO3 ratio, then the thickness of the aquifer being mapped in this region, then finally I did the model is the vulnerable of the groundwater one, moderately vulnerable. The red color is highly vulnerable, yellow is vulnerable area. So the up to based on the groundwater, then I integrated all in this region, overall multi hazards, all the hazards in this region. Okay. Then the conclusion of just I conclude all our results. Then the management strategy adopted. I think you have time or okay. Here is we are facing the problem. I already told lack of the availability data from the coastal vulnerability studies. Data is very lacking here. So same time, we have only the tide gauge stations exist in Tamil Nadu coast. Only few places only. Chennai, Nagapattinam, because highly vulnerable area. But the government set up the tide gauge area in few places only. Particularly this place, only 2 only. Chennai and Nagapattinam we have. So we need to increase the more tight gauge areas. Then the data also to give the researchers to open access, because they restricting, they never give the data from the government side. Coastal data full restrict. Even still now, coastal topo sheet 50,000 scale topo sheets is the restriction one, not possible to purchase. Okay, then yeah. Yeah, these all developmental activities should be prohibited in the vulnerable area, but this one only happening in this region. So now, then yeah, then another, yeah, so different recommendation I given in this region. Then awareness program conducted to the public. Coastal zones should protect the hard and soft infrastructure. Must be ensure the measure adopt the site results, shifting the erosion, sand dunes and sand beaches. Yeah. Most of the sand dunes now is cleared. There is no sand. Many places, particularly in the East Coast Road area, all they convert beach resorts or the industrial area. Most of the sand dunes are. So the final development must be the climate smart. Okay, this is papers. 2 papers is from the classifying the inundation limits. It's a natural hazards paper. Then one mangrove studies in this region. One paper is reference. Okay, just funding agency, just for the first study we did with we have the one European Union funding. So the project team of this European Union funding is the French Institute, my institute, and India Madras Institute of Development Study, IIT all involved, then England University of East Anglia, Research Center Slovenia, and then Norway also involved in this project. This is the study areas and work packages, different work packages in this project. Then another project with the coastal vulnerability due to climate change, sea level rise, natural hazard, with Bharatdasan University, Professor Lakshmanan. The student is going. It's funded by the Ministry of Earth Science. Then final, my institution, French institution. Actually, India is the colony of the British. Some pockets, French peoples, particularly in the Pondicherry, is a French colony. So they established French Institute. See, 1955, the institute comes under the French Ministry of Foreign Affairs and the Ministry of Research and Higher Education, CNRS, our institute. So we are nearly 80%, including both French and Indian. Most of the peoples are Indian people. So this is the one. So we having different four departments: Department of Indology, study about Indians, then Social Science, Department of Ecology, then my department, Department of Remote Sensing Information Technology. So we are having two phases. One is the Indian. If you want to consider the Indian partner, that also is possible. If you want to consider the French partner for the European Union project, you are considered as the French partner also. So we can utilize this facility for the new future project. Okay, thank you.
Thank you, Dr. Sankar. I would like to request Irasema to come on stage. ¿Podemos darle uno?
¿Los compartimos?
Y esa podemos mover.
Okay, sí.
Well, after two very nice talks, I'm sure you'll have a lot of questions to both the speakers. So if anybody is having any question, we can come to you and you can ask them. So we have next 15 minutes for discussion. So, questions from anyone?
Well, this is for Dr. Yes, very, very interesting talk. Well, I'm thinking about, this is a very industrial area, as we can saw. Have you, and of course, this affected by tsunamis in the recent years. Have you an alert systems for in order to be waiting for those kind of tsunamis? For example, a warning system, and in order to expect when these waves are coming.
Yeah. Afterwards, after the tsunami, then the Indian government, Ministry of Earth Sciences, they established one institute in Kais. Then there is a lot of buoys. They put it in the buoy. The warning system is now good. After there is a one big earthquake. It's happened 2012. That time they warned. Afterwards, the system is now sorry. Afterwards, the warning system is now good situation in this region.
2004 tsunami was the first.
So because that time we don't have any warning
After
system.
2004 tsunami, the government taken initiatives, intensified the observation points in the coastal area, and the warning system also
Now is very good.
established for tsunami alone. Not only for tsunami, for all the disasters. After 2004 tsunami only, the government established a new ministry, Ministry of Earth Science in Indian government. Then only they have the awareness program, the funding for like infrastructure, for early warning, everything they developed. Now it is okay. Now government taking very good initiatives for they have started a new ministry and a new center and a new infrastructure also for early warning and other things.
May I do a follow-up question about this issue? Yeah, actually, I have the same question than Sergio. You know, in last year, there was a tsunami induced by a volcanic eruption in Indonesia. And also after the 2004 tsunami, they have implemented a very good warning system in collaboration with Germany, if I recall properly. But then everything was left out. And although you mentioned that the system, the tsunami warning system you have now is working, who is in charge or who provides the money so that this warning system can continue work? And also about the population, I could guess you have some tsunami scenarios to see how much people can be affected. And is there any kind of strategy of communication for the people so really they know, well, first they understand what is the meaning of the tsunamis, and also they understand the tsunami systems? How do you work on that issue?
So, yeah, after the 2004, already I told the institute INCOIS, I forgot the full, INCOIS they set up in the Hyderabad region. Yeah. So full and full, they observing a lot of buoys, all they put it in the entire Bay of Bengal. They installed the buoys. Then the monitoring very well. It's a full and full Indian supported money only. Okay. So Indian government supporting the money only. Plus, they are part of the all world, the Pacific Ocean, from the USGS one. They are also part of the network, in the network only. So they are in charge for that Indian Ocean side also. If anything happen that side, automatically the message will go to the USGS side, then it will come. If now they are on the same network only. So they did also the hazard line also. Because the government, because this is a government department, they did the LIDAR data. They taken entire this coastal region LIDAR data. Then they made it the coastal hazard line also, which are the affecting area. All they prepared, but this one is not sharing to the public. Only the not public. That data is only the administrators. Collectors, every district administrative people, collectors, and this government agency only, not for our researchers and public.
No, now they have set up the early warning system through mobile communication.
Yeah, that is there.
To all the public also.
That is there.
Now they established a setup. Any disaster happening, early warning, that will go through the local community radio and also through mobile communication to email to the local public also as a warning.
This is there.
But for example, are there any maps that are available for the population before the tsunami takes place? I mean, if I want to buy a house or I am living there, can I know what is the potential impact of tsunamis in my house or in the place that I work? Is that available for people?
No, now I think before tsunami, it is completely new. Before 2004. No evacuation action plan, nothing, early warning, and nothing was there. Now they established everything. Now, if you want anything before, what was the condition before 2004? After that, around 225,000 people were casualties, very huge, and huge property loss. It's new, no awareness. Now, the people awareness creation programs were conducted, and round table conference, and through the education to the local people, even school students, local officers, local public, all awareness were created. And in case of tsunami, what mitigative steps and preventive measures should be taken, like all things are educated to the people also. Early warning.
Working with a lot of NGOs, they did a lot of things for the
through governmental and non-governmental
boards. Display boards for the tsunami. Every day fish catch also, that information they are also they doing. Where is the fish pool area? Then weather, wind direction, wind speed, all they are updating with. That is available. But this data, which your house is falling under which category, that data is still not opened up.
But not general maps.
Vulnerability maps also now available, which are all the areas highly vulnerable.
For the vulnerability maps is there.
Yeah,
Central
for the people also it is available in the website.
is there.
Yeah, from the
PDF
inquest
that is
Ministry
there.
of Earth Science website, it is available. And we have also, at the time I was working in some UN outer space research on Korean Institute. We did survey for entire Indian Ocean area, like Andaman, Indonesia, Malaysia, Sri Lanka, Indian coast, run up and inundation survey, damage assessment, everything we did, and there's a report submitted to the UN agency.
Just
Now it
PDF
is available.
format is there. That is there. Okay. Your data. Yeah.
Thanks, Roy. I'm going to make the question in Spanish. Maybe you translate to the English people. It's just because the way that the Mexican law is constructed. So it's for Dr. Irasema. Thanks for the talk. So nice. El punto es este. Si ustedes están trabajando con los legisladores, de por sí es difícil y es demasiado complicado y a veces no se entiende. Entonces, yo veo tres puntos críticos. Uno, los legisladores, la parte un poco separatista de los grandes investigadores y el gran problema a resolver para la sociedad. La pregunta es si ustedes están trabajando para que se mezclen las leyes. Por ejemplo, sí, tenemos montañas muy bonitas, pero también tenemos ahí depósitos minerales, recursos petroleros, recursos de carbón, recursos madereros. Y el problema en México es que las leyes siempre están separadas. La ley de energía geotérmica y su reglamento contrasta con la ley de aguas nacionales y su reglamento, con la ley minera y su reglamento, con la ley de hidrocarburos y su reglamento. Ahora con el fracking hay graves conflictos. Si se está trabajando en esa parte en parte.
Gracias.
Thanks, Roy.
Gracias por la pregunta que es muy interesante. Well, he's wondering about the situation about the laws in Mexico, because usually we work on specific laws. So we want to kind of solve a specific project, but we do not look from a transversal or transsectoral, a cross-cutting perspective, how we should work on the laws all together, so that although we know that there is disaster risk, we could also use in the proper way the resources, and we can bring together all these laws in an efficient way so that implementation can take place. So it's been very difficult to work with these deputies, because the problem is that they want to have, for example, there are three main issues. The first one is that they have no idea about the topic. So the president of the commission has never heard about disaster risk. And although we are lucky that she is very much willing to help us and to interact with us, she has no idea about this topic. So that's the first point. And that is not the only case. Usually it is like that in any topic you can mention. So it's the lack of knowledge of the people from the law initiatives that are in charge of this making of the laws or updating laws. The second topic is related to the timetables they have. For example, we met on Tuesday, and this lady in relation to disaster risk reduction and civil protection told me that they want to present the law on September 19, only because it's the anniversary of the earthquake. But it is not enough time really to have a proper law to fit the necessities of the people and the government. The third issue is related to your talk, your question about this cross-cutting perspective. And the idea is that we, in fact, have to review all these laws associated to climate change, to natural resources, and so on, to bring them into this law. The problem is that, for example, if you have a look at the composition of the committee, it's very heterogeneous. There is people inside that even do not understand the meaning of the law. I mean, not in terms of law, legal issues, but in terms of disaster risk reduction. So the organization and the structure of those committees are not good enough really to guarantee somehow a proper development of the laws. Additionally, we are not working with the other committees that are related to those issues. So the problem is really that although we would like to have this integrated perspective, I don't think in the government, and not only in terms of developing laws, but in terms of daily basis, we do not have the proper structure really to work together. And although, for example, that we know that there are different ministries or instances that have to do with disaster risk reduction in terms of planning, I don't know, water, engineering, and all these aspects that are related, we are not working together, not only in terms of the deputy of chambers, but in terms of every day. And now, in my particular perspective, with this new government, it's even worse. Because since I was born, I remember I was always complaining about the presidents I have had. And then the new government is, I thought that there was not going to be a worse president than Peña Nieto. And then when with all these issues that we are facing, what we are seeing is that with all these financial resources shortcuts, people is not able even to work on daily basis on each ministry. So, for example, when we had this pollution problem that was related not only to the pollution per se, but also to the fires that were taking place in the city, and of course the planning and so on. But let's take just only the pollution and the fires. What we do know, for example, is that the fire department, the firefighters, 70% of the firefighters have been fired, actually, although that is the word. And how come they can have enough resources for daily management on the issues they are used to do? So what I am saying, or what I am trying to say, is that if we do not work on daily basic from a cross-cutting or transsectorial perspective, it's going to be very, very difficult to express that into the laws. And additionally, if you add this bad preparation of the policy makers and so on, the situation, it is even worse. But when you would like to make to say something, would you like to ask something in relation to this?
Just a simple question.
Yeah.
Tan solo la pregunta es si desde el punto de vista de las grandes especialidades se está trabajando en esto. Por ejemplo, tenemos campos geotérmicos y se manejan las leyes cuando hay que definir, hay una contaminación hacia los mantos acuíferos y no hay una analítica que esté detallada en esas leyes. O tenemos instituciones salinas con manejo de costas y siento que no ha sido suficiente el esfuerzo para que esto vaya hacia adelante, ¿no? Gracias.
Yes, of course, you are completely right. There is not, there haven't been enough efforts so that we can take into account geothermal resources or what is happening in the coast or wherever you mentioned. It is not an integrated perspective that we are having, and therefore it is almost impossible really to represent that into the laws, and in addition to the problems that I mentioned before. Yes, thank you.
Thank you. We have a coffee break coming up now, 15 minutes. So I would like to request Irasema, on behalf of Mexican side, maybe she can give the Muthusankar a small gift.